Hi everyone, and welcome to SEMA. SEMA is a webinar where we invite an expert to talk about their area of expertise. This week's expert is Garth Nicolson. Garth is a PhD in MDH, is the founder of the Institute for Molecular Medicine at California, and serves as the President, Chief Scientific Officer, and Emeritus Professor of Molecular Pathology. He's also co-joint professor in the Faculty of Science and Technology, University of Newcastle in Australia. Garth created a benchmark scientific model for cell membranes known as the fluid mosaic model. This model has since become the blueprint for cellular research. He also published a paper titled The Fluid Mosaic Model for the Structure of Cell Membranes in 1972. Which is now regarded as a classical paper in cell biology. He has published over 700 scientific papers in total, mostly relating to cancer biology and cellular properties relating to aging. During the outbreak of the Gulf War syndrome, he was the leading authority on the study of the cause, treatment, and prevention of the disease. He was appointed chairman of the medical scientific panel for the Persian Gulf War Veterans Conference, and for his services he was conferred honorary colonel of the U.S. Army Special Forces and honorary U.S. Navy SEAL. In 2003, Garth turned the practice of lipid replacement therapy into a scientific concept. He observed that the therapy had anti-aging effects, restorative potential for chronic muscle weaknesses, fatigue, and was found to be beneficial to patients undergoing cancer treatments. And this is the subject for today's SEMA. So welcome to our show, Garth. Can you please begin by explaining what lipids are and what role they perform?
Well, most people think of lipids as fats, but we're not going to really talk about fats. We're going to talk about a very specific type of lipid that is used to construct cellular membranes. Now, cellular membranes are the little envelopes around each of our cells and our tissues and around every cell and every plant and every bacteria and every human and every animal has these membranes that surround each cell. So they compartmentalize the cell and allow the cell to function. But inside the cell, there are also membranes. There's a double membrane around the nucleus, which contains the chromosomes in our DNA. There's a double membrane around the mitochondria, which are the little batteries inside each of our cells that provide the energy that's necessary to drive each cell. So I'm going to talk a little bit about the mitochondria and about the cellular membrane that surrounds each cell, because these are really important. And we'll talk about some very specific things. For example, cells like nerve cells, for example, and other cells of the body that provide very specific functions and how these can go awry. Now, one of the things about membranes are that they're very sensitive to damage. And that damage can be what we call oxidative damage, where either chemicals or radiation or all sorts of things can damage these membranes. And once they're damaged, they lose function. So you can think of, for example, the mitochondria in cells as little batteries that provide the energy for the cells. Mm-hmm. So if those batteries are damaged, for example, if you damage the insulation of a battery, then the battery runs down very quickly and it can't provide any energy and your flashlight won't work any longer. Well, the same thing with the mitochondria inside your cells. If you damage the membranes that surround the mitochondria, and in particular the membranes inside the mitochondria, so-called inner membranes, then they can't provide the energy. They run down, just like the battery runs down. They no longer provide energy, and your cells absolutely have to have energy to survive and to perform functions of a cell. For example, take a nerve cell that provides a very important function. We know that. We have nerves all over our body. They're concentrated in the central nervous system, but they're also peripheral nerves that bring impulses in from all over our body. All the sensations from the exterior environment come in through our nerves. Well, if the mitochondria are not working and those cells are not working properly, we can't then provide the impulses that are necessary. Or before that happens, we often get too many impulses. And this can result in a lot of different sensations. We've been concentrating on things like pain, for example, and other symptoms that are important in my most recent clinical trial. So these are things that can go awry when our cells are damaged. So we've developed a way to repair this damage. And it's essential in our lives that we replace the components of our membranes. And we do this through diet. But unfortunately, when you get sick, your diet can't provide enough of these molecules to repair the process of the membranes so that it can regain function. So if your membranes are damaged, and this can happen by a variety of different mechanisms, then you lose function, and then very critical key events inside your body don't work right, and this leads to disease. And these are things we try and prevent.
In a normal diet, would there be enough, if a person is not sick, if someone's eating a modern diet, would there be all the chemicals necessary within that diet to allow the body to repair damaged membranes?
Well, if you ate a very healthy diet, that's true, but most people in modern times don't eat a particularly healthy diet. They eat actually a lot of junk which can damage your membranes, as well as good molecules which can repair your membranes. So we have this push and pull going on all the time of bringing junk into our bodies, which damages our bodies, and then we try and repair it with the good stuff coming in. But there's also, in our modern lives, a lot of exterior damage that occurs. Damage due to, for example, radiation, or damage due to chemicals, for example, that can damage things like cellular membranes. And this damage has to be repaired, or if it accumulates, then we can have a chronic disease process that goes on, or it can affect our aging process and can give us premature aging, for example. Membranes get damaged as a consequence of aging. So one of the important things that we've been looking at is how to reverse this, how to prevent this type of aging from occurring. And for example, we've shown in the mitochondria, which are the little batteries inside our cells, that as we age, we lose about half the mitochondrial function when you get to be 90 years old. So this is one reason why people who are 90 years old don't have a lot of energy. Frankly, it's because their mitochondria are not providing necessary energy. There are a number of other things that are wrong with them, but that's one of the things that we can work on because we know how to repair that. So we've taken a group of 90-year-olds, for example, and we've shown that we can repair their membranes and their mitochondria to the equivalent of a 35-year-old. And we can regain the function, at least in the membranes, of a 35-year-old. And those people regain energy, they regain quality of life, they can do much more than they could before. And so it's a new lease on life for people that are older. Right. And also we can prevent that deterioration from occurring, at least in the area of membranes, by providing the necessary components to repair them. So one of the things that we've done is to prepare a dietary product, a natural product, which you can take. And this natural product is like a health food. And this provides the components of the membranes, what we call the glycerolphospholipids, which provide the matrix for each of our membranes. And they're different glycerophospholipids, so we have to balance it for the different membranes. And we have to protect them. Otherwise, they're damaged before they even get to your ingestion.
There was one thing I was going to ask that, but just the radiation damage you're talking about, does that extend to cellular communications? Like a cell phone, would that be?
It can cause a lot of problems. For example, one of the things that we work with are cancer patients that are bombarded with a lot of radiation as part of their treatment. Yes. They're also bombarded with some very dangerous chemicals, right, called chemotherapy. And this causes a lot of damage to normal tissues and so on. Well, obviously you want to damage the cancer cells, but once that's done, and that usually happens very quickly, then there's a very long window where normal tissue damage occurs. And so what we've tried to do is supplement with our oral membrane lipid replacement molecules to try and help repair and prevent that normal damage from occurring so that people don't lose function. So, for example, there are many byproducts of cancer therapy. One of them is fatigue. And when that happens, it's directly related to mitochondrial function. So we try and repair the mitochondria so people don't have that fatigue associated with the cancer therapy. At least we can lower it, remove it as much as possible. But we can also repair some of the other damage that occurs because of therapy as well. I won't go into the details there, but without getting into a lot of details, it's very essential that this damage be repaired as quickly as possible. Otherwise, we have lingering effects of cancer therapy, which can be very debilitating to an individual undergoing therapy. So that's just one area. Now, there are a lot of other areas that we work with specific diseases. And one of the areas that I've worked with a lot are fatiguing illnesses. Fatiguing illnesses are called that because there's a loss of mitochondrial function in these individuals, and the consequence of that is that they feel fatigued. They don't have the energy to perform the tasks that they used to perform, and that energy is essentially provided by our mitochondria. And so the mitochondrial function is down in all those individuals. So what are fatiguing illnesses? Well, some of them are chronic, and so we have chronic fatigue syndrome, for example, or myalgic encephalomyelitis. That's another term for chronic fatigue syndrome. So these are people that are constantly fatigued and have fatigue problems that just don't seem to end. There are also people that suffer fatigue as they age, and this is age-associated fatigue. This is very common, and how can we reverse that? How can we help that? There are people that suffer all kinds of different problems associated with specific functions of specific cells in our body. And one of the areas that I'm working in right now is the area of pain. And pain is a sensation that is carried by your nervous system. And it starts in your peripheral nerves, which means out at the tips of your body, in the periphery of your body. And these nerve impulses are transmitted into your central nervous system. So these nerves, the propagation of the nerve impulse is along the membranes of each of these nerve cells. And if the membranes are damaged, then this can interfere with this. And in some ways, nerve cells can prematurely fire if the membranes are damaged. And so one of the things we've been trying to do is to repair naturally nerve cells in people to lower their pain. And we've been able to do that with just this natural medicine formulation that contains these membrane lipid replacement molecules.
That's remarkable. I find it's very interesting how mitochondria, which is a minuscule component of your cell, can have an effect collectively over the macroorganism, your body, in such a pronounced effect too. How low energy state of a cell, translates collectively to a low energy state of a person's body, and then they're unable to perform at their full potential. It's quite it's a very interesting concept, that.
Well, if you think about how your tissues are organized and how your cells are organized into tissues, each providing a specific function that you need, sometimes multiple functions, and that all requires energy. So that energy is obtained from your mitochondria. And so one of the most important things that our lipid membrane replacement molecules provide is the components to repair the damage to the mitochondria, to return the mitochondria to full function. When they return to full function, they can provide the energy necessary for the cellular function. So for all the different functions that we have in all the different cells of our body, that's driven by mitochondria. So if the mitochondrial function goes down, then they can't, our cells can't function properly. So we lose functionality of those cells. So for all the different things that cells do in our body, that provides a way to lose that function. So just while I'm looking at you on the screen, of course, that's a visual perception. I also have an audio perception because I'm listening to you. And all that is driven by very specific cells that require energy for those functions. And so if the mitochondria are not working properly in the cells that provide those functions, and we lose that function. We no longer hear as well, we no longer see as well, and so on and so forth. So you can see how this can impact on every different system of our body.
That's amazing. Now, it's one thing to create a molecule to help the body repair itself, but you've got to get that molecule to the target, which is the cell. And there's a few obstacles if you take it orally. Now, as well as saliva, you've got stomach acid.
That is the really key element of what we're doing, because what we're providing are molecules that are already in our cell membranes. And so we have a natural mechanism for bringing those molecules into our body, transporting them to where they're needed, and inserting them into the membrane and taking the damaged lipids out, in the reverse process, getting rid of them.
You've got to be kidding. You really?
We use that natural mechanism, and it's even more interesting than that, is because we've evolved as essentially from our past as really hunters. We were hunter-scavengers before we were farmers and before we actually grew food. And as scavengers, we've evolved with the system to capture these very important molecules from our food, because if we didn't get these, we weren't going to survive. And as hunter-gatherers, we didn't have a normal diet day-to-day that provided these molecules. We had to go out and capture animals or other plants or anything to provide these, and we often didn't have these things around, so we had to, it was feast and starve is the way we evolved. So we've evolved with a very spectacular system for when we're in the feast mode, for capturing all of these important molecules. All these important molecules, in our case for membranes, are called glycerolphospholipids. And the glycerolphospholipids that we get, for example, from other animals' cells that we eat, we recover those molecules as much as possible. But if we were to take those molecules in one by one, we would never be able to get enough molecules to repair the damage that's occurring normally, let alone with disease. So that's really not the way it works. Well, the way it works is that if we give a massive quantity of these, which is what we do with our natural medicine, our oral products, we bring in a bunch of it all at once, and we have a mechanism to actually capture these lipids as small little lipid droplets and bring them into our system and circulate them throughout our body, and our cells will pick these up and store them and transport them and move them around the cells and put them in the various membranes where they're needed, and so on and so forth. We have this really amazing system of capturing these molecules, shuttling them to where they're needed, and replacing the damaged molecules that are there. And then we have a reverse system that takes the damaged molecules out and essentially sends them out in our stool through the gastrointestinal system. And so we've actually been able to utilize that reverse flow to remove dangerous chemicals from the body. And that's another amazing aspect of this whole story, and that's what we've been working on right now with people that have been chemically contaminated, and removing those dangerous chemicals from the bodies and doing it in a way that doesn't cause them severe symptoms in the process.
Gosh, it sounds like science fiction. It's just so unbelievable, just incredible.
Well, it turns out it's not science fiction at all. It's the science that we've evolved with. And so each of us, you and I, were born with the system to be able to do this. We just really needed the right way to provide these molecules so that this could work in optimal fashion. And that's really what we've done. We've designed these molecules so that they could be ingested orally. And we've also had to design a way to protect them, because if they're so sensitive, for example, to all these different damaging chemicals and radiation and oxidative events and so on, we had to find a way to protect them. And that's where we go back to the plant kingdom, because it turns out the plant kingdom has provided a way to protect these molecules. It's a molecule that is present in all plants and vegetables, and anything that's leafy or green or whatever has these molecules in it to protect the membrane. So plants that, for example, trees that survive freezing temperatures and boiling temperatures and so on, so they can survive all these different extreme temperature swings, have these molecules to protect the membranes. So we've utilized these molecules to protect our lipids in our natural medicine products. So these are natural molecules themselves that nature has provided to us. So we put these in to protect our lipid replacement molecules in our formulations. And so they can be ingested. They don't have to be injected into the body. They can be just taken in orally, and they can be picked up and transported and so on without being damaged. Because if they're damaged along the way, and by the way, most lipid supplements are damaged, either in storage of the product on the shelf, for example, natural oxidation occurs, or in ingestion, they're damaged. In our gastrointestinal system, for example, in our stomach and in our intestines, there are acids, there are molecules, there are bacteria, there are all these kinds of things that are there to help break these lipids up. But if we have these protective molecules, we can actually get these into our system without their being damaged. And that is absolutely key. And then we just flood the system with these molecules. And by doing that, it's kind of like a conveyor belt. And as the conveyor belt comes in and all these molecules come in and they replenish all the damaged molecules, then the damaged molecules get on the backside of the conveyor belt and they're shipped back out. And it's what we call a mass action or bulk flow mechanism that allows this to occur. So you just need enough of this stuff each day to get that conveyor belt moving, and then you can remove the damaged lipids and the chemicals and everything while you're getting in these important molecules to repair your organelles like mitochondria and the cellular membranes and everything else. So it's really a fascinating area to work in, to see all this going on at the same time. And to be able to provide people with a natural product, which can do this naturally.
Wow. It ticks all the boxes. I've had a question come in from T.A. King. He asks, are your membrane lipid replacement molecules redox signaling molecules?
Well, they are in that these molecules come in as molecules which are fully reduced so that they can repair the molecules that are in our cells and in our organelles. If they're oxidized, it turns out they're damaged, and they really can't go in and replace the normal lipid molecules that are in our membrane. So we have to protect it from being oxidized. So we put in some antioxidants and so on, and it turns out if we put in the excess lipids themselves, that they act as an antioxidant.
Good gracious.
Yes, they are redox sensitive, and that's very important because when they go in the cellular membrane, they have to be in a certain state, a certain reduced state of oxidation, so that they can not only repair the membrane, but they can form a leak-proof membrane. So one of the things that happens, for example, when we age or in disease processes, these membranes become leaky, and because of that, they can't provide the chemical potential across the membrane that's important for the membranes. And without getting too technical, that potential across the membrane is very important, and that's how many things work. For example, like our nerve cells work and transmit impulses. That's how our mitochondria work to produce energy and so on, is to maintain this chemical electrical potential across the membrane. So that's why the battery analogy is so important, because if those membranes are damaged, then we get leak across the membrane, and then the potential across the membrane is destroyed, and they no longer function. They no longer work. They can't be used to provide high energy molecules anymore. So without getting really detailed, that's an important aspect of what we do. Provide the right molecules to go to the right place.
And you were saying before that you put them in great numbers, quite great quantities. So you're guaranteed that some make successful passage, some healthy ones make successful.
Well, it turns out that's important. This bulk flow process, we didn't really respect it at first because you think that, well, you put in some molecules and this will work. Mm-hmm. But we didn't realize that not only do we have to put in some molecules that will help the systems work, but we have to flood the system to remove the damaged molecules, because if we don't remove the damaged molecules, we still can't get a fully functional membrane system to work the way we want it to work. So that's why this bulk flow concept, mass action complex, is so important to think of it. So we have this conveyor belt process that we bring in these massive amounts of these glycerophospholipids, and they not only replace the damaged lipids, but they also in the process bring out the damaged lipids. They remove them from the body, and they're excreted out in the stool, for example. So we just eliminate them in a normal, perfectly normal way.
Wow. Another question that Tia King asks, which is very relevant with your comment just now, are your molecules native to the body?
Yes, they are. And that's critical, because we can't replace the molecules in our cells with foreign molecules. They have to be the right molecules. There's some little minor modifications that go on once inside, for example, the mitochondria. And there's some specific new lipids that are made, so we can provide the glycerophospholipid precursors to those new lipids. So some important lipid molecules, for example, that can't be transported into our body, they have to be synthesized in situ, that is, right inside the different organelles. And in the mitochondria, for example, there's an extremely important lipid called cardiolipin. And cardiolipin, if that's damaged, the mitochondrial function goes down. There's a direct relationship between the damage of cardiolipin and the loss of function. So one of the things that we've done is we provide the precursor to the cardiolipin, because cardiolipin, we can't put that in a product. It's not a vitamin that you can add, for example, because it's not transported. So it's not even taken into our system. But what is taken in are the precursors to that. So the glycerophospholipid precursors to cardiolipin are taken in through the natural process. And what we do is we provide a lot of these so that when they get in the interior of the mitochondria, then they're very easily modified by the enzymes that are there into cardiolipin molecules. And those are inserted into the membranes, and then those cardiolipin molecules restore the function of the mitochondria. So that's one case where not only is it lipid replacement, but it's providing precursors to important lipid molecules that are there, but you can't bring them in as a part of your diet, for example, or a part of natural medicine.
Right.
We have to make them ourselves, and providing the precursors in high enough amounts helps that process along.
I was going to ask the question, like, I mean, you're ingesting lipids and they're going through intestinal tract, and you've found a way to sort of allow them to pass through, but to get them to pass within the cell membrane. And you're saying that it is possible, and actually to provide all the building blocks, if you like. So
remember, these are the lipids that are in our membranes anyway.
Yes.
So to get them to pass through the membrane is actually quite simple. We provide high enough amounts of these, and they actually come in our system through our intestinal system as tiny little droplets of these lipids. And our system senses the composition of those droplets, so it allows them in. There's a gating process that allows these in because they're important molecules. So we have this feast or famine type of evolution that allows massive quantities in, because for our survival, we needed that to occur. And so we've evolved with that system. So that system brings in these molecules, and then they're shunted around all throughout the system into the circulation, for example, and then they're presented to cells, and the cells have a mechanism to engulf and pull these things into the cells. So they're actually sucked into the cells. And the reason they could do this is because the composition of the glycerophospholipids is the same as the glycerophospholipids in the membranes themselves. So it's very easy. They're very compatible to bring these things in that way. So these little droplets are sucked inside the cells, and then they're shunted around the cells, and then these little membranes can fuse with other membranes and deliver these molecules to where they're needed. So it's a very intriguing process, and I'm simplifying it a little bit because it's really more complex than that. But I think for our purposes, that's all we need to know is that it works, and we've evolved with this system, and we can bring in these massive quantities, and they can replace the damaged lipids, and we can do the reverse process and get those damaged lipids out just by this mass action process or bulk flow process. It's a conveyor belt. We keep the conveyor belt going, and we can bring out the damaged molecules on that conveyor belt, doing the reverse back out again.
Now, in a modern diet where one may not, with the modern foods which taste fantastic and they've got a nutrient value, a negative nutrient value, if you predominantly eat those types of foods which truly have what could be no lipids, but a lot of chemicals, but not many lipids, what would the result be to your body? Can your body survive?
Eventually, you will utilize the lipids. They'll get damaged, and if they're not replaced, then they'll try and work in the membrane, but the membranes will become leaky, and they can't maintain the potential, chemical, electrical potential across the membrane any longer, and so we slowly lose function. So we have to provide these things, and diet provides some of them, but we can't provide enough of them during the disease process to repair all the damage that's been done. So in a normal, healthy individual who's eating a good diet, for example, getting the right amount of the lipids and the proteins and everything else necessary in the diet, they can maintain that function quite nicely. But in disease process, it can't be maintained because they're being damaged at a greater rate than they're being taken in and replaced. Also, as we age, they're being damaged at a greater rate than we can actually take them in and repair them. So that's another area that we've worked on, and it's important. So we have to have a way of replacing these. So a lot of the lipids that we take in are already damaged. So what happens then? Well, it's like bringing junk into our bodies that's already been damaged, already been oxidized, for example, in the case of the lipids. And this interferes with this whole process because these molecules compete with all the other good molecules, and it just dilutes out the good molecules and slows the whole process down. And if it's slowed down to a point where it is no longer replacing the molecules that are being damaged at a given rate, then our membrane systems start to deteriorate. And this happens actually during aging. And so we can, one of our areas that we work in is anti-aging. How do we slow down or prevent this process from occurring? And one of the things that's important is to keep these molecules coming in to repair the damaged molecules so that we're not so dependent upon our diet.
Gosh.
Now, eating a healthy diet is important, but how many of us really, truly eat a really healthy diet every day? And probably damn few when it comes right down to it. And all the junk that we eat with all the chemicals and all the bad stuff and all the sugar and all the other crap that's in it, this really interferes with this whole process. And so that's why our modern diets are really hurting us in a way that they're giving us a lot of junk that interferes with these natural processes, and they're bringing a lot of junk in our bodies that we have to eliminate eventually, because it's not really helping us that much. It's actually hurting us. So,
but even a healthy diet, cooking from home, the act of cooking is exposing food to such a temperature that if it's a vegetable, the cellulose breaks down, or if it's a meat, if it's a meat.
It depends on how it's prepared, and there's a way to prepare it so that you can reduce the damage. Obviously, we've evolved with heating foods, and the main reason for that is to kill bacteria, which pathogenic bacteria, not good bacteria, are damaging to our system, and we like to prevent that from occurring.
Right.
So we've evolved with heating food to prevent that. But in the process, we damage a lot of the molecules that we take in, and that's not good either. So we have to. What we've done is we've used a natural medicine way of bringing in these molecules in an undamaged state in a protected environment so they can be taken in and shuttled to where they're needed and replace the damaged molecules and help bring the damaged molecules back out again. And as we age, it's more and more important to have this very pristine source of molecules to help replace and remove the damaged molecules.
So is it better to eat raw foods if you not having to cook the food for hygiene reasons, like salad with fresh greens and tomato and avocado?
There are a lot of people that suggest that, well, the secret is raw food, but it's not so much that as it's also the type of food. for example, there's some people that are vegetarians, and they know that if they're vegetarians, there's certain things that they really have to eat, like beans. Otherwise, they don't get, for example, the lipids that they need in that type of diet. So we can't just live off of lettuce alone. After a while, we just die, because we can't get enough of the lipids from lettuce or greens or leaves or whatever. So we have to have other things. So even vegetarians know that they have to supplement with beans. Well, it turns out to get enough of these glycerophospholipids, if you just supplemented a vegetarian diet with just beans, you'd have to eat one heck of a lot of beans. And so it's really easier to just supplement with these purified molecules that are protected each day with membrane lipid replacement. That's what we've done. We've provided a product where people can either take a powder and put it in their food, or they can take little wafers that are chewable, or they can take tablets if they want to take it that way. And however they do it, they can get these lipid molecules in at the rate that they're needed, particularly if they're suffering from a disease or a chronic illness in particular, because they need more than a normal person would need, because they have a lot more damage that's been going on in their system and is occurring every day in their system. So they need special help. And that's one of the things that we provided with natural medicine with these products. And the product that we developed is called Defects. And I won't go into where the name is. I don't really like the name so much myself, but that's stuff for you. So Defects lipids are the types of lipids that we've been talking about. And these are actually obtained originally from plant sources. But you couldn't eat enough of these plants to provide the lipids. We're not talking about tank car quantities of eating of these types of plants and so on. So we have to isolate and concentrate these lipids, and that's what the product does. Is it takes the very specific types of lipids that are in the membranes and concentrates and gets rid of the bad fats and all the lipids that we don't want, and just gives these membrane lipids in a concentrated form. And so you can take it again as a wafer, as a powder, as a lot of our patients, for example, like this new energy powder that's now being sold by a number of different companies. And this powder, just the glycerophospholipids themselves, there's no fillers, there's no colors added, there's no flavors added. And so it's a colorless, odorless, tasteless powder that can be added to any food or any drink. And so it's a very easy way to get the amount of lipids that you need on a daily basis. And so that's one of the things that I've really been pushing. And a lot of people really like this product. Now, in our clinical trials, we use it in a different form. We use chewable wafers. And the reason for that is we have to control the amount that each patient takes each day and each parts of a day for purposes of the trial. So we have to put them on a standard intake. And the only way to do that is to give them these wafers, because otherwise they'd be taking too little or too much, or they'd be going up and down each day if they were taking the powder. But a lot of people like the powder. And we deal a lot with children because children have a lot of these mitochondrial problems, particularly children that are damaged from vaccines, for example, or have autism spectrum disorders. So these are children with Asperger's syndrome, autism, attention deficit disorder, and so on. These children really have a real deficit of their membrane. So we need to really give them a lot of these lipids. And so we give them these chewable wafers, and kids love them. They're berry flavored, they're chocolate flavored, and so they take these things and they think they're candy. So again, it's in a form that the children like, so we don't have a problem of compliance. The children love them, they eat them every day, and so it's part of their normal diet. So they get the lipids they need, and it helps them with the process. In the case of these children, it helps reduce the damage in their systems, and it helps them recover from these neurobehavioral problems that they have as children. So these are some of the things that we're doing. As I mentioned, we're working with older people, and we're also working with people with a lot of chronic illnesses. And lately, I've been working with a lot of people that have problems with pain and other symptoms, and very specifically working with fibromyalgia patients. And so these are patients that have a lot of widespread pain all over their body, and it's because their peripheral nerves are firing all the time. one of the reasons I've hypothesized that this occurs is because the resting potential across the membrane of the nerve cell is diminished because of the leakiness of the cells, and the nerves are firing just all the time. And so you're getting that sensation of pain from the actual pain nerves and receptors and transmitting into the central nervous system, and that perception is constant pain. And so we've been able to reduce that pain just by giving this natural lipid product, this natural medicine. And people take that these very healthy medicines, and they're really not medicines. They're just it's natural medicine. These are just natural products. They take this in the right form, and it's helping them with their pain. It's helping them with their gastrointestinal symptoms. It helps them with their fatigue. It helps them with a lot of the problems that they have. Right now, we've been working on the male end of it, but we're going to start working on the female end of it as well. And also on the in vitro fertilization part of it, because all of these things turned out to be very dependent upon membrane function and improving viability and so on. And so one of the areas that we're just going to start up is how do we improve storage, for example, of ovum and sperm? And there's a huge commercial area that this operates in, which is animal husbandry.
Yes.
And so one of the groups I'm working with is in Montevideo in Uruguay, and I do work with the University of Republic of Uruguay down there, and we have some projects ongoing, and they're of course very interested in how to preserve things like sperm and eggs and so on for in vitro fertilization. It's very important for their luck industry, for example. And we're also working in the area of human sperm, which is what we started with, because I'm interested in disease. And there are many diseases that occur because of male infertility, for example, because of problems with sperm. If sperm aren't motile, they're not going to be fertile. And so we've been able to improve fertility by different mechanisms. One is by improving the mitochondrial function, because sperm carry mitochondria in a little sheath next to the sperm head. And if those mitochondria decline, then sperm motility goes down. So there's a direct relationship between mitochondrial function and sperm motility. So we've been able to jack up the mitochondrial function, increase the sperm motility, and improve their fertilization capability. So that's one thing that we've been able to do. But also the membranes themselves become leaky, and by repairing the membranes directly with these lipid products, that improves fertilization. And so on the female side of it, the production of ovum is very dependent upon the proper lipids, the proper membranes, and so on. And the whole fertilization process depends upon it. So we've been able to improve in couples, for example, that have fertility problems. We've been able to provide them with these lipid supplements to help improve their fertility. So that's another thing that we're just getting involved in right now. And there's a whole area of storing gametes, either eggs or sperm. And it turns out that using our NT factor lipids, this natural product, we can improve the ability of those cells to recover from storage, from freezing damage, and so on. And just like cells in a tree recover from sitting in snow for months at a time, and they're perfectly healthy again and start to regrow, we've been able to figure out that problem as well with the sperm and the eggs when we store them by freezing them. So that's one whole area that I've really been intrigued with and been working on for a number of years. And so that's really going full bore. And then there's the various disease processes. Now, I was discussing diseases like fatiguing illnesses that are directly related to mitochondrial function. Turns out there are a lot of other diseases that have a lot of other problems associated with them that are directly related to nerve cell membrane function. So you can imagine all the sensory diseases. So loss of vision, loss of hearing, loss of tactile function, loss of muscle function, so on and so forth. All these are very nerve cell dependent and so on. And so as our nerve membranes deteriorate, there are problems that can be associated with this. And so we've been interested in getting involved in a lot of those different areas as well. So that's the future for us, is that we're going one by one into these various disease processes and seeing what we could do with this natural medicine product.
With people that have got fibromyalgia or chronic fatigue syndrome, other chronic diseases, in your trials, you've really said that your products have helped them. But is it long term? Do they have to continue taking the added lipids, or
Yes, they have to continue. It's a lifelong process. And the reason is these conveyor belts, you can't just shut them down and expect that everything will be fine, because the membranes will still be damaged. The whole disease process will still go on. Because remember, we're not really directly interfering with the disease process. What we're doing is repairing the damage that the disease does and recovering function because of that. So if somebody has an infection, for example, we know that we can help reduce the side effects of the infection, but we have to keep going with this product. Even after the infection is waned, we have to still keep giving the product. And so as an anti-aging product, you have to continuously give these lipids probably for the rest of your life if you want the full anti-aging benefit, because as soon as you stop it, then your membranes start to run down again. They start to get oxidized and damaged, and function starts to slowly go down again. So this is something that we have to continue to do. So that's part of this whole process, to convince people that they have to get on these products and stay on them, just like I do every day.
Well, you've certainly got lots of energy, you know. And
well, I'm 75 and I hope to be around for another 30 years. So I'll be around and continue my work for 30 more years, and I better do something about it now. And so I've been taking these lipid products now for the last 10 years or so, and I'm sure this has improved my health. I mean, it's maintained my cognitive ability, my sensory ability, and particularly my fatigue. So I plan to continue this process.
Wonderful, wonderful. If you remove if you have your lipid supplements, and your conditions get better, then your membranes, will they actually recover themselves, become less permeable, less leaky?
They do recover. They recover their function.
Okay, so at that point in time,
they recover their function naturally.
Okay, and so at that point in time, maybe you can reduce the amount that you need to take?
We think the amounts for anti-aging are actually less than the amounts that we actually have to give during, for example, the disease process. In the disease process, we think that all this damage is accelerated. So we have to swamp it out with quite large amounts. But once we get over that, we can get down to a residual level that just replaces the normal molecules that are damaged on a daily basis through daily living. And so we can cut back a bit on it, but we still have to continue it.
Okay. Are there any foods that are naturally high in the lipids that we require?
Oh, sure. I mean, you can, for example, fish sources of lipids are very good because they're very high source. The only problem is that many of these fish lipids that people take, fish oils, for example, become rancid very easily. That is, they become oxidized very easily and damaged. And so if those lipids are damaged and you take them, you're putting junk in your body that's not going to help. It's going to hurt. And that means you got to take even more of the undamaged molecules in to replace those damaged molecules. So we prefer the natural product that we get from plants to make sure it's not damaged, and remove all the damaged molecules and protect it with antioxidants and protect it from other types of damage during the ingestion and transport process. And that's, I think, the best source of lipids to repair your membranes.
Okay, so fish oils, are there any plants which are high in lipids for the benefit of the vegetarians watching the show?
Oh, yes. In fact, our products are plant-derived. They're not derived from mammals or fish or whatever. They're derived from plants. And what we have to do, though, is we have to purify them to get rid of all the other stuff that's present in plants. And your body's not going to do that naturally. So we have to provide that product.
I understand.
With a very supplemented source of the particular type of membrane lipids that are important.
Right. So which plants would be highest in lipids, like the source, before you remove all the
Well, there are a lot of plants that are high in lipids, and again, it's not so much the plant source; it's the process that you go through to enrich for these very specific molecules. And for example, the anti-factor lipids, the original lipid source is soy, but there are no soy proteins or anything that can cause allergic reactions to soy. So that's the first thing that I have to warn people, is that we're just taking these lipid molecules that are in your cells already. So they're not foreign. They're the same molecules that are there already. And we have to enrich them and remove all the soy allergens, the soy proteins, the soy carbohydrates, and so on that can cause allergic reactions. So the soy lipids themselves do not cause any allergic reactions. So although soy is what we start with, what we end up with is essentially universal lipid molecules.
I understand.
And that's important. So people always ask, soy, oh my God, they're soy derived. And it's, it's non-GMO soy.
Yes.
So it's, all these important things that people worry about. We've taken care of, we've thought about, and it seems to be fine.
Wonderful.
I need to turn on a little light here. And let's see.
Well, and there we have Professor.
A little better.
Professor Garth Nicolson. He's so committed to finding a natural way of extending your life and extending your quality of life that he's even using natural light in this webinar.
Well, we started with natural light, and we had to end up here with a little help because the sun went down. So out here in California, in Southern California. So that's nature for you.
Yes, and our bodies often need help as well, and your products provide that help. Do you have a website, Professor Garth, where people can look and see what work you do?
Yes, I'm going to give you two sites. The first one is the Institute for Molecular Medicine.
Yes.
And that's www.imed.org. It's like immediate.org. Just think of immediate.org, and you'll do imed.org. So that's the Institute for Molecular Medicine, and they could just go down the areas that they're interested in. Fatiguing illnesses, cancer, infectious diseases, or whatever people have an interest in. They can click on those areas and take a look and see what's been done. We've also worked out some treatments for various types of diseases and using natural molecules, and people can look at that. So that's one area. The other is that the products themselves for this natural lipid replacement, the source of that can be found at ntfactor.com, one word, ntfactor, FACTOR.com. And on that website, which is a commercial website, they can find out about various products. And those products are sold on a lot of different platforms and a lot of different companies that sell these: Allergy Research Group, iHerb, Nutricology, Amazon. I mean, you name it. These products, you can find them because they're pretty widespread now. But the original place and where they're made is called Nutritional Therapeutics, and that's the ntfactor.com. So, and that's one place that they have, some explanations of what's going on that you won't find in Amazon. And so that's why we first like people to take a look there.
Thank you so much.
Money from selling these products or whatever, that's not what I do. What I do for these companies, I run clinical trials and I run evaluation of the products, and we run tests on them and so on and so forth. So, I don't try and push products that can be bought through a number of different sources, and I don't make any money on that. So I got to give that but for full disclosure, I am a consultant to this company, Nutritional Therapeutics, and I consult to make sure that their products are appropriate, that they work, and that we can test them in clinical trials and prove that they're doing what we say they're doing. And that's very important.
It's hard to, talking to believe that you're actually of retirement age. You've got the sharpness and energy of someone much younger. And so thinking, what are you doing must be working.
Well, I hope so, and I hope it'll continue to work because I want to be doing this for the next few decades and improving people's lot in life along the way, and also helping them with the aging process and helping them with the disease process, no matter what they have. So we've kind of figured out that these products are good for anybody with a chronic illness, and they're probably pretty good in people that have a lot of acute problems as well.
Mm.
So another area that I'm very interested in is sports medicine. So in the future, we're going to be going into that a bit, trying to improve performance because we know we can improve mitochondrial function. And this, of course, is interesting. I work a lot with veterans, as you know, because I work with veterans from the Gulf War. And we're doing studies, and for example, we're very interested to know how armed forces personnel, how they operate at high altitude, for example. We know that this can help with altitude problems. And so we have people using these in the mountains of Afghanistan, for example, to see how our armed forces personnel perform under those conditions and so on. So again, there's a lot of different uses for these. We're just really fortunate to be able to study these and really enjoy doing this kind of work.
It's absolutely fascinating. Well, thank you so much for coming onto our show, and thank you for explaining this all to us. And thank you, viewers, for tuning in, and we'll see you on the next webinar. Thank you very much, everybody, and thank you so much, Garth, for coming on board.
You're welcome.
Goodbye.
It was a pleasure.
That was incredible, Garth. It really was. We sort of ran out of time. I wanted to talk more about the Gulf War, because you found that there may have been a bacterial link in the Gulf War syndrome.
Yes, this actually goes back. We had a family member that served the Gulf War and came back with Gulf War sickness because of the Gulf War, and about a third of the deployed forces, American, Canadian, British, Australian, for example, forces came back with this problem. Interestingly, the French did not, and I'll tell you why in a moment.
Oh, wow.
So what we've pinned it down to eventually was the fact that there was possibly some contaminants in some of the military vaccines, and these were specifically the vaccines that were given to the armed forces of the countries that I just mentioned, but not to the French. And so this is why the French didn't have a problem with Gulf War illnesses, but all the other nations did that I mentioned. And we were working with that problem, and would make a long story short, we were going through the various aspects of that. And while we were trying to figure out what was wrong, we found out that the families of the veterans were starting to get ill when the veterans returned to the home. So that ruled out a lot of things. That ruled out chemicals, for example, that ruled out depleted uranium, that ruled out a lot of different things that could cause chronic illness. But it didn't rule out infections, because you can really, if you pass something to your family members after you come home, it's most likely to be an infection that you carry and pass to your. And so we started from the signs and symptoms profiles, we started looking at a lot of different possibilities. And so we finally figured out that it was a very unusual little primitive bacteria called a mycoplasma, and a very specific type of mycoplasma called Mycoplasma fermentans that seemed to be infecting responsible for about 1/2 of the Gulf War illness, because there were a lot of different illnesses associated with the Gulf War. This was just one major problem. So we found that the families that were getting sick were due to this problem specifically. So we could trace the family sickness back to the veteran, back to their problems with this particular infection. So that we set about trying to figure out ways to treat it and solve that problem.
Wow.
And so that's our experience with the Gulf War veterans. And because of that, I made a lot of contacts in the military, and we were able to look at some of their problems in the future wars, not only with infections and those kinds of problems, and with biological warfare problems, but also with problems of fatigue, with problems of environmental stress, with problems in all kinds of different problems that are associated with deployment of armed forces personnel and so on. So we got involved in doing little things that would try and help this. Well, that's another thing I'm very interested in.
If the Gulf War syndrome was caused by bacteria, again, why didn't the French get infected?
Well, because the French didn't take the vaccines at the other countries.
So the vaccine actually contained the bacteria?
Yeah, it turns out there's a fairly high incidence of contamination of mycoplasma in commercial vaccines. And one publication indicates that 6% of them are contaminated. So we think that a lot of the armed forces personnel got injected with a contaminated vaccine that contained these microorganisms because they're very specific. Mycoplasma fermentans are very specific. And although mycoplasmas in general, you find them often associated with certain diseases like atypical pneumonia, for example, that type of mycoplasma is really quite different. It's a mycoplasma called Mycoplasma pneumoniae.
Mm-hmm.
And in chronic fatigue syndrome patients, that's the most common mycoplasma in North America. But in Europe, the most common mycoplasma is Mycoplasma hominis in these types of patients. So what we're talking about with the Gulf War illness was Mycoplasma fermentans, which until a few years ago was relatively unknown.
Wow.
So that was one of the things that suggested that this was something unusual that happened with the Gulf War and the vaccines from the Gulf War. Now, the reason we think it's the vaccines, it's not that we've proven it, but it's a hypothesis, was that armed forces personnel that were vaccinated and deployed came down with illness at a fairly high rate.
Yes.
If they were deployed without vaccination, they didn't come down with illness. However, there are small numbers who were vaccinated because the war ended so quickly and were not deployed. Some of those came down with the same type of illness as the Gulf War illness, same signs and symptoms profiles and so on, and the same infection. So that's why we think that it was really part of the contaminants that they received in the vaccines. Now, once somebody has that contaminant and they become sick, then these are airborne infections as well, so they can pass these to family members. So as the Gulf War veterans came back to the home, they probably passed their infection to family members via an airborne route, but they can also, there are other ways to pass the infection to their spouse. Fluid exchange, for example, either sexual contact or even kissing can transfer these types of infections as well. So the profile in the families were that the spouse was becoming sick the quickest, and in the children in the family. And not all the children became sick generally in the family. So the ones that became sick had the infection, the spouses that became sick had the infection. And so it was exactly the same infection, this unusual Mycoplasma fermentans that we found in the veterans. So that's how we were able to solve that problem. And then we worked out some treatment protocols, and people were put on these treatment protocols and they recovered.
Good.
So, long, slow process of recovery. But as part of that recovery process, this membrane lipid replacement is something that we use as well in that recovery process. So this is all interesting stuff to a lot of people, but in particular, it's very interesting to veterans who have been inoculated, for example, with the anthrax vaccines and other vaccines that may have contained these contaminants.
Gosh, but I mean, a lot of people will probably be still watching us, and the burning question in their mind is vaccinations which are done now, are they still possibly contaminated with an unknown bacteria? I was under the assumption that they screen absolutely everything out except for what they wanted to.
They don't screen for mycoplasma, for example. There's an interesting story that I tell about this, which is really kind of funny, is that I was on my way to Washington, and I happened to be in Philadelphia at the time. I was lecturing there, so I was flying down to Washington I had to meet with some VA people down there. So I got bumped up to first class, which is, was really fun for me. And I was behind a couple of guys that were flying down from a very well-known pharmaceutical company in Philadelphia, and they were flying down to Washington. And they were, talking about vaccines and so on and so forth. So I just flat out asked them about, do they ever check their vaccines for mycoplasma contamination? And they looked at each other and said, no, why would we do that?
You're kidding.
Because there are publications in the literature that indicate that if you randomly just check commercial vaccines, that this one publication indicated that 6% of them were contaminated with mycoplasma. And they looked at each other, and one of the guys turned around and told me, he said, are you trying to put us out of business? And they sort of avoided me from then on. They wouldn't talk to me. And so I learned my lesson about talking to pharmaceutical executives who are, put profit first. Let's put it that.
Well, I mean, how else can they afford the seats that they're riding in? First class.
Well, exactly. But, that's not the way I think about it. The way I think about it is you make the best, purest product possible, which is what we do with our membrane lipid replacement. And if it costs a little more, that's the price that we have to, charge, and that's the cost we have to bear. It's not that we want to do it. It's just the logical thing to do, is to make it the best thing possible. But here are these people that are trying to do everything to hold the line on prices, and they're willing to sacrifice, some contamination here or there. They don't even know about it. It's not that they didn't even want to know. That really bothered me, and I've related that in some of my lectures, and people are aghast. There's a gasp that goes up in the audience. What do you mean they didn't want to know? They just didn't want to know, because if they knew, then they might have to remove, 5 to 10% of their vaccine lots from commercial sales, and that would be catastrophic to their bottom line. So
just to clarify and to ensure I understand you correctly, people that have become autistic or in some other way come down with a chronic disease after vaccination, that this could well be due to a contamination of the vaccine rather than the designed contents of the vaccine.
Well, we think it's probably, there are several different things going on here with vaccines. And I know there's been a lot of focus on some of the adjuvants of vaccines, in particular heavy metal components of vaccines. We've concentrated on the biological elements that are present in vaccines. And so that we think is a problem. And if you look at, for example, autistic children that became autistic after their multiple childhood vaccines, we found that 2/3 of them have mycoplasmal infections in a study that we published in a very reputable journal, highly ranked neurological journal, study we did in Northern California, because there's a lot of, in certain counties, there's a lot of autism cases and so on. But we do know that something like autism and autism spectrum disorders are very complex neurobehavioral diseases, and depend upon a lot of different insults, this being one of the biologic insults because of infection. So mycoplasma was the only infection we found, but it was a very important one in these patients. But many of these patients also had chemical contamination, heavy metal contamination, and so on. So we try and look at this holistically. I don't like that term, but we try and look at it that way. And so we try and take patient groups like this and say, well, how can we treat X, Y, and Z? X, Y, and Z being, let's say, infections, chemicals, and heavy metal. And so there are ways to deal with all of this. And if you start dealing with all of this, then the patients start to get better. And so that's one of the things that we've been trying to do. So that's something I've been involved in here in California, and it's been very rewarding, working with these families and working with these groups of autistic children.
Wouldn't it be lovely to have a multivitamin tablet and lipids? See lipids listed there, the anti-aging lipids. Wouldn't that be good?
Well, it's, again, it's something that eventually people are probably going to be taking as their normal anti-aging process. I just anticipate in a few years that there'll be not just our product, but a number of different products that people will, be able to take for anti-aging purposes. They won't only contain the lipids, but they'll contain other things as well to help preserve function. The lipids are just part of the whole problem, of course, and it's the part that we're dealing with because we can't deal with everything. So we're dealing with that specific aspect of it. It's something that we can test. It's something we can run clinical trials on. It's something that we can measure performance on. It's something that we can look at signs and symptoms and see if people are improving. We can look at aging and parameters of aging and see if we can change those parameters and so on. So that's something that we can do, we can measure, and we can work with this membrane lipid replacement. But in the future, it'll be more complex than that. There'll be a number of things that automatically lose function because of genetics, for example, that we may be able to reverse. There'll be things that Other things that are functionally important in aging, that there will be replacement molecules for those. There'll be molecules to stimulate regeneration of certain organ systems and so on that are important. And all of that will be involved in anti-aging products and remedies in the future.
It's fascinating. Garth, as fate would have it, we've just had one last question come in, and it's an interesting one. I was just wondering, before we pull the plug, if we can just answer this one question.
Absolutely.
It's from Lorena. She asks, can you please give the correct spelling of that bacterium that we were talking about before that was within the vaccine?
Okay.
And she was asking if there are any papers written concerning the bacteria contamination of the vaccine.
Yes, there are. And you can go on our website, again, immed.org, immediate.org. You can look under Gulf War Illness Research, and there are a number of papers that we published on this subject. You can delve into those to your heart's content.
Yes.
So most of the vaccine work that we did has not been published, primarily because we had some interference with that, and I won't go into that, but it's a politically hot potato topic, as you can imagine.
Sure.
And other people have published on contamination of vaccines and so on. What we've done is we've looked at people that have received those vaccines. Do they have certain infections like mycoplasma? And that we have done, and so some of those publications are on our website.
Okay, and the spelling of the
it's going to continue on for years, I'm sure.
Absolutely. And the spelling of the Mycoplasma pneumoniae.
Oh,
how do you
just say MYCO, Mycoplasma, PLASMA. And the mycoplasma that we studied was Mycoplasma fermentans, FERMENTANS, fermentans. So that's just go on our website. You don't have to memorize it. You can just look on our website, go to Gulf War Illness Research, for example, or infectious disease research. You'll find tons of papers and reviews and so on. You can lose yourself for quite a long time in those, I'm sure.
Expect a bit of traffic over the next few hours.
No, but that's fun. We like traffic.
Thank you so much for your time. And sorry to sort of extend beyond that, but it's just a subject hard to sort of walk away from, because it is very, very interesting.
Well, you can have me back sometime. We'll talk about the Gulf War and all the problems associated for something like that, for example.
Okay.
Because I could go on at least for an hour on that topic alone.
Wow, thank you so much for your time, Garth. You must be starving. You haven't had dinner yet. Okay,
well,
goodbye.
I have some soup waiting for me, by the way. I have some bean soup waiting for me. So.
Okay, thank you so much again. Thank you.
No problem.
Goodbye, viewers.